In this chapter, which is chapter 7 of year 2, we're going to look at some more trigonometry and some more applications of trigonometry too. The first thing we're going to have a look at is something called the addition formulae. Now the addition formulae, they're given to you in the formula book. You can access the formula book on the SharePoint page. I think it's in the key resources page as a link to it. And it's these three formulae here. This is what they look like. Now, within each of these formulae, there is actually two formulae sort of contained within it. So this first one, sine of A plus or minus B, is sine A cos B plus or minus cos A sine B. So there's two forms here. There is sine A plus B, and when it's a plus, then you take the top symbol from here as well. So this is then sine A cos B plus cos A sine B. And then when it's a minus, the symbol in the middle is a minus. So we've got sine A cos B minus cos A sine B. And the same is true for this formula here. However, notice here that I've got a plus minus. The symbol here is minus plus. So when it is cos A plus B, this is cos A cos B minus sine A sine B. And likewise, when it is A minus B, we'll get cos A cos B plus sine A sine B for that one. Okay, so basically each of these has got two formulae contained within it. The last one for tan. Tan of A plus B is tan A plus tan B divided by 1 minus tan A tan B. Because when I'm using the top symbol here, I use the top one from this one and the top one from this one. When it's tan A minus B, then I'll get tan A minus tan B on top. And on the bottom, I'll get 1 plus tan A tan B. Okay, there we go. So we've actually got 6 formulae here. You don't necessarily need to remember them. They are available in your formula book. And I'm going to show you later on where these formulae actually come from. But first of all, we're actually going to just get started on applying these formulae and using them, and we'll look into where they come from again later on. Now we're going to look at, this is exercise 7a in the textbook, questions 5 to 9, but I think I'm actually going to go through them on screen with you now, just to show how to use these formulae. And this is obviously just some examples of how we can use these formulae. So the first question here, using the expansion of cos A minus B with A equals B equals theta, show that this identity here that we already know is true. So let's use the expansion. So it says cos A minus B, the expansion that I showed you a minute ago. So it's cos A cos B plus sine A sine B. Now it tells us to use A equals B equals theta. So basically A and B are both theta. So this would become cos of theta minus theta equals cos theta plus sine theta sine theta. Cos theta minus theta, well, that's cos of 0. Cos of 0 is 1. And then on the right hand side, we've got cos times cos, which is cos squared theta plus sine squared theta. And there we are. And that's another identity that we know is true. So we can use one to show the other as well. Okay. This next one, number 6. Use the expansion of sine A minus B to show that sine pi over 2 minus theta is cos theta. So let's use the expansion. So sine A minus B, that is sine A cos B minus sine B cos A. And now if we substitute in pi over 2 and minus theta, sorry, pi over 2 and theta is A and B. So this would be sine pi over 2 minus theta. It's going to be sine pi by 2, so we're obviously working radians here, cos theta, minus sine theta cos pi by 2. Now, the bits that have got angles in them, so it's got pi by 2 in it, we could actually just work out what those are as a number. So sine of pi over 2 is just 1. So this is just going to become 1 cos theta minus, now cos pi over 2, you could do this on your calculator, make sure it's set into radians, is 0. So this is actually going to be sine theta times 0. So our answer is then cos theta. Okay, so sine of pi over 2 minus theta is exactly the same as cos theta. It's an interesting result. We can show this geometrically if you have a right angle triangle. So maybe this is length 1, then this angle here is theta. This would be sine theta, and this length would be cos theta. Now what we could do as well on here is label this angle here. If this is theta and this is 90, obviously angles in a triangle add up to 180. This angle at the top is going to be 90 minus theta if we're working in degrees, or if we're working in radians, it would be pi over 2 minus theta. Which means that this side here, relative to this angle at the top, this is opposite this angle over here. So this would be sine 90 minus theta, or sine pi over 2 minus theta, if we're working in radians. Likewise over here, this is adjacent to this angle here, so this would be the cosine of 90 minus theta, or the cosine of pi over 2 minus theta. So we can see that cos theta is the same as sine pi over 2 minus theta, and sine theta is the same as cos pi over 2 minus theta. Let's do part B of this question as well. So it says use the expansion of cos A minus B to prove the other result that I've just shown you with the triangle. So let's just go straight into it. So we'll do cos pi over 2 minus theta. So it's going to be cos pi over 2 cos theta plus sine pi over 2 sine theta. And now I can work out the bits that are actually numerical. So cos pi over 2 is 0. So we've got 0 plus sine pi over 2, that is 1. So that's just sine theta. And then we've proved our result. So cos pi over 2 minus theta is just sine theta. Okay, number 7. Write sine of x plus pi over 6 in the form p sine x plus q cos x, where p and q are constants to be found. So I'm going to use the expansion, sine of x plus pi over 6. So using the addition formulae from before, this is going to give me sine x cos pi over 6 plus sine pi over 6 cos x. Now again, we can work out the numerical part. So cos pi over 6 is root 3 over 2. So this is root 3 over 2 sine x plus sine pi over 6 is 1/2. So that's plus half cos x. So in this case, p is root 3 over 2 and q is 1/2 for this question here. Look at another similar one here. Cos of x plus pi over 3 in this format. So I can write this as cos x cos pi over 3 minus sine x sine pi over 3. Work out the numerical parts. Cos of pi over 3 is 1/2. Sine pi over 3 is root 3 over 2. Okay, so in this case, a is a half and b is minus root 3 over 2. Okay, for this one, express the following as a single sine, cosine, or tangent. I'm just going to put the formulae on the screen at the same time. Okay, so I've got the formulae there so I can use them to compare. Now this expression here, this looks quite long and complicated, but the key thing to spot is just what pattern is it. This is sine cos plus cos sine. So that's going to be this top formula here. So this is going to be equivalent to sine of 15 plus 20, because it follows this format here. But a is 15 and b is 20. So this is the same as just sine 35. Likewise, this one here, sine cos minus cos sine. That's this one here, but when we've got a subtract in the middle. So this is going to be sine of 58 minus 23. 58 minus 23 is 35. So this is the same as sine 35. Looks quite different to sine 35, but it is equivalent. This next one, cos minus sine sine. So this is the second one, the cos addition formula. So this is equivalent to cos of 130 plus 80, because when we've got this negative sign in the middle, that was when it was cos A plus B. So this is actually the same as cos of 130 plus 80, which is 210. This one here, this is obviously the tan formula. It's quite different to the other ones. So this is tan, is a negative on top, or a subtract sign. So that means that it's going to be A minus B. So that's 76 minus 45. So tan 31. This next one, the pattern here, cos plus sine sine. So that's going to be the cos formula, and it's going to be cos A minus B. So this is cos of 2 theta minus theta, which is of course the same as cos theta. So they look quite different, but they are equivalent. This one here, cos minus sine sine. So this is the cos addition formula. Looks like this. It's got a negative sign in the middle, so that is when it's A plus B. So this is cos 4 theta plus 3 theta. So that's cos 7 theta. This one here, sine cos plus cos sine. This is the sine addition formula. And it's got a plus in the middle. So this is A plus B. So it's going to be half theta plus 2.5 theta. So a half plus 2.5 is obviously 3 theta. So this is sine 3 theta. This one here, this is going to be the tan formula. And it's got a plus on top. So this is going to be tan A plus B. So this is tan 2 theta plus 3 theta, which is tan 5 theta. Okay, question I. Sine A plus B times cos theta. So we've got sine cos minus cos sine. So that is the first one, the sine addition formula. So this is going to be sine. Now it's got a subtract symbol in the middle, so it's going to be A minus B. In this case, A is A plus B. And then it's going to be subtract, I'm just going to put an extra bracket around this, A plus B, subtract B. So this is actually the same as sine of just A. This last one here, the pattern, cos minus sine sine. This is the cos double angle formula, it looks like that. It's got a subtract in the middle, so this is going to be cos A plus B. So this is cos 3x plus 2y over 2 plus 3x minus 2y over 2. We've just got to add those together. So this is going to be cos, on the top I'm going to have 6x, and I've got 2y plus minus 2y, so that's 0. So I've just got 6x over 2, which is obviously the same as cos 3x. Okay. So we can use these identities and use the patterns that they have to reduce some of these more complicated expressions down to simpler ones. There's a couple of slightly more tricky questions in this exercise, 15 and 16. You can have a go at these. Well, there's a work solution in the book, or I've got one there. You could pause the video and use that for number 15. And then also question number 16. Maybe we'll have a look at 16 now. So prove that this expression here is equal to 0. So we've started off with cos theta plus this one here we can expand. So this is going to be cos theta cos 2 pi over 3 minus sine theta sine 2 pi over 3 plus then this expansion here. Maybe if I put a bracket around each of these just to make them a bit more separate. Cos of this plus this, that's going to be cos theta cos 4 pi over 3 minus sine theta sine 4 pi over 3. And hopefully we can simplify this and get to 0. So cos 2 pi over 3 is minus a half. So I've got minus 1/2 cos theta. This one here, sine 2 pi over 3 is root 3 over 2. So that's minus root 3 over 2 sine theta. Next one, cos of 4 pi over 3 is minus a half. So it's plus minus 1/2 cos theta. And the next term, sine of 4 pi over 3 is minus root 3 over 2. And now you can see from this, I've got cos theta minus a half cos theta minus another half cos theta. So these all sum to make 0. And then I've got minus root 3 over 2 minus another root 3 over 2. That's not 0. So let me just correct that, because this should be because minus sine theta sine 4 pi over 3. Sine 4 pi over 3 is minus root 3 over 2. So actually it should look more like that for the last term, which then gives you a positive root 3 over 2. And then this and this cancel out, and then we just get 0. There we go. Okay. Next thing I'm going to look at is how we actually derive these formulae. So we've done using them already, and now we're going to look at actually where do these 6 formulae come from. Now the way that these are derived, we can actually start by us looking at the area of this triangle here, this diagram here. Okay. Now I've labelled some of the angles. I've called one angle theta, and I've labelled one angle phi. And I'm going to use this because I've essentially got one large angle here, which is phi plus theta, and then I've got 2 smaller ones. So I can use that to help me derive formulae for theta plus phi and theta minus phi, and so on. Now, the idea that I want us to just look at, first of all, is the area of the big triangle. And when I say the big triangle, I suppose I should say the triangle ABC. Okay. That is equal to the smaller triangles added up. Okay. So that is equal to the area of triangle ADC plus the area of triangle DCB. Okay, so basically the area of the big triangle is the 2 smaller ones added up. Hopefully that's fairly obvious so far. Now, to work out the area of a triangle, we could do half base times height. What I'm actually going to do here is use half AB sine C. Okay, which we used plenty of times before when we were studying trigonometry in year 1. And half AB sine C, remember, it's got to look like this. Right, this is your angle C, and the sides either side of it are A and B. Okay. So to do that, the area of the big triangle, that's going to be half. This side is A, and this side is B. It's half AB sine, the angle between them is theta plus phi. Like that. The area of the triangle on the left, that's going to be half. One side is B, and the other side is h, so that's half bh sine theta, plus the other triangle on the right, that's going to be half a times h times sine phi, because we're looking at this triangle here. Okay, so here's my expression. I'm also going to now replace h with something in terms of a and b. Okay, so I'm going to look to try and replace this h with something in terms of a and b, because I've got quite a lot of different variables here. So I'm going to leave this side the same. Okay. Now, this h here, if we look at each of these triangles, instead of h, if we focus on this triangle here, I could write the height in terms of a. I could say that the height here is a cos phi. Okay, because it's adjacent to phi and the hypotenuse is a. So I'm going to write this as half b, and instead of h, I'm going to call it a cos phi sine theta, plus, then the other one I'm going to call half a. Now I'm going to describe h, but in terms of b. So this would be b cos theta, okay, because this triangle here, this is adjacent to the angle and b is the hypotenuse. So this would be b cos theta, and then times sine phi. Okay, so I've got quite an interesting looking formula here, but it's got all of the right elements in it that I need for my first addition formula. Notice that every single term has got half AB in it. So I've got half AB here, I've got a half AB, I've got half AB. So I'm going to divide every single term by half AB. And that will just leave me with sine theta plus phi equals sine theta cos phi plus sine phi cos theta, which hopefully you recognise as being the first addition formula. This is sine A plus B. So there we go, that's our first formula. Now the next thing we're going to do is we're going to use this formula to help us derive all of the others. Okay. So the first one to go for is probably sine A minus B. Okay, so just instead of having a plus in here, we're going to have a minus instead. So to do that, I'm just going to let phi become minus phi instead. Okay, so now my expression is going to become sine theta minus phi. Then we'll have sine theta cos of minus phi instead, plus sine minus phi cos theta. Okay, now that's obviously not quite the formula that I'm looking for, but we can do something else. We can think a bit more carefully about what these minus phi's are. Let's deal with the cos minus phi first of all. So here's the cos graph. This is 0 in the middle here. When I do, say, cos 30, maybe that's here, that's the same value as I get when I do minus 30, because it's symmetrical. So you can say that cos of phi is actually exactly the same value as cos of minus phi. Okay, you could try it on your calculator. Cos 30 will give you the same value as cos of minus 30, because it's symmetrical about the y-axis. So in this first bit, instead of writing cos of minus phi, I could actually just leave it as cos phi. Now let's think about sine of minus phi. Let's draw the sine graph. Okay, when I do it here though, so if I put in this angle here, so say this is 30, we do it with numbers, it's always easier to think about, I get 0.5. When I put in minus 30, so here, I actually get minus 0.5. So I sort of get the same answer, but it's just been times by minus 1. So what that means is that sine of minus phi, so sine of minus 30, that's exactly the same answer as when you get sine of 30, but times by minus 1. So I can say sine minus phi is negative sine phi. And again, you could test this on your calculator as well to sort of prove it to yourself. So this means that this negative, or this sine negative phi, is actually just going to be minus sine phi cos theta. And this is our second addition formula. This is the formula for sine A minus B. So we've got our first two formulae. We've got our sine addition formulae here. The next thing I'm going to do is try and come up with a formula for cos. Now, hopefully you remember me talking earlier about a right-angled triangle that looks like this, where this is 1, this is theta. So we can say that this is sine theta, and this is cos theta, so the adjacent and the opposite. Now, we also then talked about this angle up here would then be 90 minus theta, and we could do it all in terms of that instead. So if this is 90 minus theta, this side is now opposite 90 minus theta. So we could write this as sine 90 minus theta. And we could describe this side, which is adjacent to this angle, as cosine of 90 minus theta. So sine theta is exactly the same as cos 90 minus theta, and cos theta is the same as sine 90 minus theta. We're going to use that to derive the next pair of formulae. So we're just going to use our sine A plus B formula for earlier. So that was sine theta plus phi. We could instead write as sine theta cos phi plus sine phi cos theta. And now what we're going to do is we're going to do let theta become 90 minus theta, because then we can use that to change between sine and cos. So the bit on the left is going to become sine 90 minus theta plus phi. So I've just replaced the theta with 90 minus theta equals sine 90 minus theta times cos phi plus sine phi times cos 90 minus theta. Now I'm going to try and use these ideas here in the red triangle to change some of these. This bracket here I could actually write as sine of 90 minus, then in a bracket, theta minus phi. I could write it like that, because then I've got 90 minus theta and minus minus phi to give me this. Now sine of 90 minus an angle is the same as cos of that angle. So this left-hand side now becomes cos of this angle here, so theta minus phi. So this is how I've changed between sine and cos. Sine of 90 minus theta, that is equal to cos theta. And we've got sine phi, cos 90 minus theta, that is equal to sine theta. And now I've got my addition formula for cos A minus B. Okay. Now, to get the next formula, which is obviously for cos A plus B, we're going to do exactly what we did before with the sine formula. So we're going to let phi become minus phi to get the other one. So this is now going to become cos of theta plus phi, because I'm doing minus minus phi. So that would then be cos theta cos minus phi plus sine minus phi sine theta. And from the same thinking as before, where we considered their graphs, and exactly the same reasoning, cos of negative phi, that is exactly the same as cos phi. So this is cos theta cos phi. And hopefully you remember that sine of negative phi, or sine of a negative angle, is exactly the same as minus sine of that angle. And then we've got our formula now for cos A plus B. Okay. So we've got our sine addition formula and we've got our cosine addition formula. So the last two we need to get are just the tangent formula. Now, a good place to start to get our tangent formula, we know that tan is sine over cos. We know that well by now. So I could write tan theta plus phi as sine theta plus phi over cos theta plus phi. So the sine formula, which was sine theta cos phi plus sine phi cos theta, all divided by cos theta cos phi minus sine theta sine phi. So I've used my two expressions. Now this doesn't quite look like the tan formula. The tan formula had a 1 down here, if you remember, or if you look back at it, it had a 1 down here. So to generate that 1 down there, I could divide every single term by cos theta cos phi. So I'll show you what that would look like. So I'm going to divide everything by cos theta cos phi. But because I'm doing it to the top and the bottom, this is valid because it won't affect its value. So I've got sine theta cos phi divided by cos theta cos phi plus sine phi cos theta over cos theta cos phi, all divided by cos theta cos phi over cos theta cos phi minus sine theta sine phi all over cos theta cos phi. Now we can start simplifying this down. So sine theta cos phi over cos theta cos phi. We can see that this is going to become just tan theta because these two cancel out. This one here, the cos thetas cancel out, and I'm just left with sine phi over cos phi. So that is tan phi, all divided by, this term is 1, minus, now here I've got sine theta over cos theta, which is tan theta, and sine phi over cos phi, which is tan phi. So this is going to give me tan theta tan phi. And this is my expression for tan theta plus phi. There we go. Now the last step is to do exactly what we've done for all the others. We're going to let phi become minus phi. So we've then got tan theta minus phi equals, so this is going to be tan theta plus tan of minus phi all over 1 minus tan theta tan minus phi. Now I need to think about how this works with the tan graph this time. So the tan graph looks a bit like this. It looks the same here. In fact, I'm only going to draw that bit. I don't need anything further on. When I put in, say, 45, so if I put in 45, I get 1. When I put in minus 45, I get minus 1. So that means that tan of minus phi, so tan of minus 45, that is negative tan 45, or tan phi. So you can use that to help us. So that means that we're going to have tan theta. Tan of minus phi, that is minus tan phi. On the bottom, tan of minus phi, that becomes negative tan phi. So this is going to become plus tan theta tan phi. And now we've got all of our formulae, all 6. Now, you don't have to be able to reproduce the whole thing from scratch, obviously, in an exam. That would be much too much. But they may well ask you questions involving the proof. So you have to be aware of it and have seen it before. So they could ask questions that involve some of the steps on this proof, maybe. Okay, it might say, like, here are some steps from a proof that a student's done, spot the mistake, or something like that. Okay. Okay, I'm just going to do one more type of example. And we've seen some like this in the last chapter as well. So it says, given that sine A is minus 3/5, and that A is between 180 and 270, and cos B is minus 12/13, and B is obtuse, so that means that B is bigger than 90, but less than 180. Find the value of these expressions here. So the first one, cos A minus B, this is one of our addition formulae. So let's expand this and write this in a different way. This will be cos A, cos B plus sine A, sine B. Now, I don't know what cos A is. I know what sine A is though. And I know what cos B is, but I don't know what sine A is. So I need to work out some other things before I can use this formula. So let's just do that as an aside over here. So let's find cos A, first of all. And we've done this before several times on this style of question. So we know that sine A is minus 3/5. And we know that sine squared plus cos squared is 1. So that means that cos squared is 1 minus sine squared. So I can calculate cos A. So I can do 1 minus sine squared, so 1 minus 9 over 25, and then square root it. And that'll give me cos A is plus or minus 4/5. I then need to decide which one it is. So there's my cos graph. And it says that A is between 180 and 270. So that's between here and here. So it's just this portion of the graph here. So that's negative. So cos A is minus 4/5. We also need to find sine B to be able to use my formula. So I'm going to do exactly the same thing. So I know that cos B is minus 12 over 13. I'm going to use sine squared plus cos squared equals 1. So that means that sine squared is 1 minus cos squared. So if I do that, then sine B, so 1 minus cos squared, so that's 1 minus 144 over 169, and then square root it. That would give me plus or minus 5/13. Need to decide which it is. Let's draw the sine graph. Now it tells me angle B is between 90 and 180. So between 90 and 180. So it's just this portion here. And I can see that as positive. So sine B is positive 5/13. And now I can plug these into my formula. So cos A, that is minus 4/5, times cos B, I was told that in the question, that was minus 12/13, plus sine A, sine A was minus 3/5, and then sine B, that was positive 5/13. And I can then just calculate this as a number, and I will get 33 over 65 for cos A minus B. There we go. Now to find some of the other results, I can do a similar sort of thing. Hopefully now that I've worked out quite a few values, these should be a bit easier. So tan A plus B, I can use my addition formula, tan A plus tan B over 1 minus tan A tan B. Now, I don't know any of my tan values, but I do know all of my sines and coses, so I can just write these all as sine over cos. So tan A is sine A over cos A, so that'd be minus 3/5 over cos A, which is minus 4/5, plus tan B, so that's going to be sine B, which was 5/13, over cos B, which was minus 12 over 13. And on the bottom, 1 minus, and then both of these expressions again. So that's tan A, and times tan B. I suppose you could do some of this working out beforehand, but I've just written it as one big expression, really. And we can work out what this is equal to. So I've worked out some of the values of just these fractions. So this one is 3/4, this one is minus 5/12, this is still 1, then this is obviously 3/4 times minus 5/12. I'm just going to work out this final step. I'm just going to type this whole thing into my calculator, I think. And when I do that, I get a final answer of 16 over 63. Now, the last one that I need to work out was cosec A minus B. Now remember cosec, this is 1 over sine. So this is 1 over sine A minus B. So that is 1 over sine A cos B minus sine B cos A. And I can just fill in my values that I had before. So this will look like that. So sine A was this, cos B was this, sine B was this, and cos A was this. And I can just work out what this fraction is equal to using my calculator. And when we do that, we get to 65 over 56 as your final answer for cosec A minus B. So quite long in terms of actually plugging the numbers in, but the important bit here is probably this bit in red really, which we've done several times before. So just finding out those other values and thinking about are they positive or negative by looking at the graph. Now that was quite a long lesson, but actually we've done quite a lot of questions in here. We did loads from 7a together, we looked at these harder ones, we did deriving them. So the only ones that I've picked out really is just practicing some questions that are like this. So you might want to have a go at any of question 5, 7 and 9 from exercise 7b. And those are just questions that look like this. If you can do one of them, then that's probably fine.